Okay, we want to find component form in our quadrant 3 here, given a vector of 77 in magnitude and a direction angle of 253 degrees. With this one and with the next video that I'm going to post, these are pretty straightforward. We've already seen two previous videos like this. If you've not watched those yet and this is your first time, the important thing that we're going to want to keep up with is that our x component is going to be the magnitude of our vector. We already mentioned that that was the 77. We're going to multiply that by the cosine of our angle, which is the 253 here. So we're going to jot that down. We're going to get 77 times cosine of 253 degrees. And this comes from the fact that we can run some basic right triangle trigonometry on this to make sense of it, and I've done so in previous videos, so if you haven't seen that yet, feel free to go back and take a look. But we also saw that in the same way. To find our y component, we can take our magnitude of our vector v and multiply it by sine of theta. And this was because our y component was our opposite side relative to our thetas. And so here we go in and we say, well look, that's going to be the magnitude of 77, and this time we'll use sine for the 253 degrees itself. And then that's going to be pretty straightforward. We're just going to grab a calculator. We're going to throw these values in there. We're going to hope that we're in degree mode. So we'll take a look here. We are. I know the calculator is a little fuzzier on the screen than other things. I can try to focus in case you want to see that while I type this. Let's see, 77. Yeah, that's still tightened in on the writing. It didn't really care much about the calculator. That's okay. 77 cosine of 253. That gives me a negative 22.5. And then down here, we'll just go ahead and hit second enter again. And I'm just going to scroll over and replace cosine with sine because I'm lazy. That's probably the same number of keystrokes realistically. This is going to be approximately negative 73.6. So this one did not round up because we had that little 3 behind it. And the 5 didn't round up because we had the little 1 behind it. So here, what we're going to do is we're going to say, well look, this would mean that our vector v in component form, we tend to use these angle brackets, is going to be negative 22.5. Always list your x first. This is a lot like writing an ordered pair. You always do x and then y. This is negative 73.6. So that's our vector v. And I just want to run a couple of quick checks to make sure that this is correct, which I'm already pretty convinced of it. But when I take a look at this, I would say, well, first of all, if I did the Pythagorean theorem here, well, it's a little bit clearer on this side of the camera. Here we go. I would do 22.5 squared, and I would do 73.6 squared. And you would ask potentially why I didn't include the negative numbers here, but it should be noted that negative values being squared, if you type them correctly, so keep it in mind, here would be like negative 22.5 squared, and negative 73.6 squared, you would see that you get the exact same value because negative numbers, when you square them, if you properly have your parentheses in here, negatives times other negatives just give you positive values. And we're working with a positive square root here. We're measuring a distance, a magnitude of these vectors. The hypotenuse does always end up being positive. And you can see here, if I round to 1 decimal place, we actually do get exactly 77 this time, because the 6 will bump up to 9, which will then bump this 6 back to a 7. So on these, you're going to get numbers that are slightly rounded off when you check like this, but that's not too bad. The other check is that we are supposed to be in the third quadrant. 253 is pretty close to 270, so it's going to be something kind of like this. And we're going to say, well, it has a negative 22.5, it's got a negative 73.6, so we're seeing something smaller here, something larger here. And if we really think about it, if we want to go in here, we could subtract 180 from 253, and we're going to see that this angle here is 73 degrees. If this angle is 73 degrees, then this side should be the larger side by a fair amount, which it was based on what we just saw. So everything seems to be checking out. We have the correct quadrant, we have the right magnitudes, the general size of everything. This seems pretty solid to me.